All right, so let's take a look at this. We have 4 raised to the x plus 2 raised to the x is equal to 72. And what we want to do here is we want to solve for x. So when we take a look at this, on this side, I'm able to represent this using a base of 2. So I'm going to focus on the left side here. I'm going to represent 4 to the x as 2 squared raised to the x, and then I have plus 2 raised to the x, and this is equal to 72. Right, so we have that. Now, and looking at that, because the power is raised to a power here, I'm able to switch these. So basically, I could take this and I could interchange it. I could put x here and put the square out there. What this does for this question is that it is actually giving me this quadratic field right now where I am now able to say, hey, I could take this. I could take 2 to the x and make it y, or I could make it any variable I want. So let us say I intend to say, let us take 2 to the x and let us turn that into y. So 2 to the x, let's turn that into y. So let's take a look. So 2 raised to the x, we are going to let that equal to y. So I'm going to rewrite my statement there where I'm taking 2 to the x and I'm going to let that equal to y. So let's take a look. So here it is. It's going to be y squared, because y is now 2 to the x plus y, and then I'm gonna, because it's a quadratic, I'm gonna subtract the 72 from both sides. So I'm gonna have a minus 72 over here. With that said, this is where we are now. We're looking at y squared plus y minus 72, and that is equal to 0. So let us now factorize this. But because my coefficient of the square is a 1, it's a easy factorization. So I'll have y plus 9, and then I'll have y minus 8, because 8 nines is my 72, so I was able to factorize that easily. Now with this said, we could say, hey, it's either y plus 9 is a 0, which would have made y negative 9, or it's y minus 8, and that is a 0, and that would have made y 8. So y is 8. So I have 2 responses, one where y is equal to negative 9, and one where y is equal to 8. What we're going to do now is to go back and recall. So let us recall that 2 raised to the x is equal to y. So since 2 raised to the x is equal to y, then on y is negative 9, I could say, hey, 2 raised to the x is equal to negative 9. So I'm substituting the negative 9 for y. And then when I look at this one, I'm like, there's no real number that could do this, because there is no real number that 2 could raise 2 to give a negative answer. Okay, there is no number that I could put where x is as an exponent here and get a negative response. So this one, it is not valid right now, right? So let us now focus on the other idea. For the other idea, y is equal to 8. So I could say 2 raised to the x is equal to 8. Okay, so this is equal to 8. And then I'm seeing something here that I could do. I'm able to represent this 8 using a base of 2. So what I'm looking at is 2 raised to the x is equal to 2 raised to the third. And as you could see, if I have any equation where I have 2 quantities looking at, where on the left side we have a base of 2, and on the right side we have a base of 2, which means the base is the same. So whenever I have the same base on either sides, we're dealing with 2 things, it means then the base would have canceled themselves. So as you could see, x is actually equal to 3, and this is the valid solution that we'll take from this. See you next time. Bye-bye.